Time is a fascinating subject which philosophers and theoretical physicists spend a lot of time talking about. I've devoted about 60 pages, one chapter in my last book, to the topic of time, but I'm not going to spend so much time on it here. I'm just going to give you basically my overall message, my overall approach to thinking about time. And it's quite different from the standard approach. So normally you'll hear time and clocks, the relationship between them discussed in the following way. Most theoretical physicists think that clocks are devices that measure time. And I think it's okay to think of them as that. But it's much better, I think, to think of a clock as a model of a system. So a clock is a model, and there's some other system, and we're measuring a property of that system. This way, we don't run into as many immediate conceptual problems of how to define time. Because if time is something abstract and a clock is something concrete, and you're relating this concrete object to something abstract, it does create problems. Maybe I can illustrate that shortly. But as an intermediate step, it's better to think about, whether or not a clock is accurate depends on its relationship to the system that it represents. So all of the Earth-based clocks are really models of a system which we know as the Earth-Sun system. It's mostly based on the rotation of Earth. So if a clock is correct, then it tells you what the Earth is doing. It tells you what the Earth is doing in its rotation and also in its orbit around the sun. And that's it. Nothing more than that. Now, if we want time to be more abstract, we can also incorporate other things. We can consider other systems as well and try to, abstract away from that. So here's a little saying that I have that I think gets my point across. If the temperature in the environment is hot enough to melt our clock, then this does not imply that time itself has melted. By the same token, if your clock speeds up or if it slows down, this does not necessarily imply that time itself has sped up or slowed down, unless we understand the clock as simply a device that measures time and we assume that it's always accurate. We have to always keep our mind open to the possibility that a clock, any given clock, is measuring many other things other than just time. So, so let's say we are measuring the rotation of Earth. That's what we're measuring, not time itself, but just the rotation of Earth. But at least if we understand this connection between the clock and the Earth, we are making a step in the right direction. Because our conception of time actually depends on what type of clock we're considering. So, in Einstein's conception of time, in special relativity and general relativity, time is considered to be local. And the entire reason for that is that the only types of clocks that are considered under this framework are what we would call local, meaning that they are small in space and that they are essentially objects that are held together, so they're not moving in multiple directions and multiple speeds at the same time. They are a singular object. And this is part of what's responsible for Einstein's conception of time, which I completely disagree with. I think it's arbitrary because let's say we considered a rotating galaxy to be a clock, and we based our standards of measurement and our definition of time on that. In that case, we would have something that was definitely not local, because the different parts of the galaxy are moving in different directions at different speeds, and because the whole galaxy is massive. It's not a local object. So another good example would be if you had a pendulum clock on the moon, and you had an atomic clock on the moon. The pendulum clock is going to be ticking slower than an Earth-based clock, even though it's exactly the same machine. Meanwhile, the atomic clock is going to be ticking faster on the moon than one on Earth, even though it's basically the same machine, it works the same way. So what happened to time itself? That's an open question. We don't have to say, well, the atomic clock is correct and the pendulum clock is wrong, or we don't have to do it the other way either. Rather, we can acknowledge that the atomic clock, both the atomic clock and the pendulum clock, depend on other things other than time. The rate at which time flows is only one factor among others that influences what the clock does, and the clock is just a model. It's not time itself. So that's more or less where I'm starting. And I also have a lot of problems with using atomic clocks as the de facto definition and standard for time measurement and for defining time. I think that's about all I have to say about that for now.